So, heaven yours me, Deepak. I'm welcoming you to this video where we're gonna learn about big data and all the important concepts related to it. So, yeah, before jumping into whatever we're gonna study and the concepts and much more about it, before delve into it, I just wanna introduce that's what do you mean by big data. So big data is what, if I want to define that, means it refers to data sets that are so massive, and at the same time it's fast moving as well, and it's so complex that traditional data processing software can no longer manage them. It's generally, if I'll say, let's say ideas over data, let's say it's and if it is in a limited storage or limited data ideas have, then I can easily store it somewhere. Let's say ideas have structured data, so I can store it in some SQL database management system, might be in the Oracle or someone I can just use some database and also stuff in order to store all the data over here inside this. But what if the data is itself massive? Is that massive that I can't, it's the scale is getting keep on increasing day by day. Because earlier what used to happen, because earlier initially 20 years or something like that, years ago, we were only be exposed to web 1, where we are just reading, we are not writing anything from the web. So there's a data was just what, that was just read heavy. But nowadays if you look, the data is write heavy as well. Why? Because from the web 2 onwards, what happens that it says that okay, now you can read like earlier, which you used to. Now you can write as well. Now we are in an era where we can easily engage with anyone in this world. We can make networking, we can showcase our talents and all the stuff. We don't need to go to some door and knock, hey, at this talent at us. So in order to connect, in order to see this, in order to interact in any way, we have social medias, we have many things, like Instagram, like Facebook, and a lot more, like Twitter. We have everything. For let's say if I want to learn something, if I want to share something, I can share in a form of video in the YouTube. I can share an article in the Medium and whatnot. I can share a lot of things, anything, to anyone in this world. So I'm not limited to what, just reading. Now I can write as well. So with the time, this right thing has been increased a lot, because earlier people were not used to generate this much of data. But now what happens that people are, means generating a data in a massive pace. uh, if you'll consider Twitter, LinkedIn, Instagram, whatever, let's say they have billions of users. If let's say one user also, if they are making, if that particular user is making 10, if let's say one user is making 10 tweets in a day, then how much will it be in a day? Then let's say there are billions of users, let's say not billions, if just 100 million users is making 10 tweets in each day, so it becomes how much, it becomes a lot, means it becomes 100 million users are making it. Okay, 100 million into 10, this, let's say if each tweet, if let's say each tweet is of, let's say, even if it is a kb, let's say for the simplification 1 MB, it can has image as well, but that's also a huge. But let's say, considering, let's say one tweet size is 1 MB. So in that case, what will this be? So in that case, this will be what? This will be, if you carefully consider 100 million into 10, it's what? It's 1000 million. Are you getting it? What does it means? It says that uh, if I'll consider it in the case of 1 MB, so it means it becomes what? Means if I say, let's say if tweet is there is of 1 MB, then it explodes in just a day. It becomes exponentially high. It becomes what? It becomes, if I'll come to the point, that it becomes around if not, it's not just gigabyte, it's terabyte, it's petabytes. It becomes one more zero. So earlier it was million, now it's 300, so billion, billion, now it's petabytes. So it results me into what? It's now what? Now it's 1 petabyte in just a day. And it's not the exact, I'm saying, I'm just giving an estimation, and also not considering the worst case. So now the data is growing in an exponential phase. It's becoming petabytes, and it's not the petabytes. There are in a peak time, and normally as well, it is now coming at the quintillion of data. Miss, if I have to be if I have to explain you that, miss, it's not just this. Nowadays, means if I have to say that, it's 2.5 quintillion. Can you imagine this 2.5 quintillion in just this decades of years, something like that, decade or 2 decades of years? Means we generate 2.5 quintillion bytes of data every single day. That is a number with 18 zeros. Means here, it's 18 zeros after that. That's not a small number. That's a huge, huge, huge. And it's just from one platform. There could be a lot of other platforms as well. So this is what we call the data explosion. That means today we are diving into this engine room of the modern world that is called as big data. And but here, this big data isn't just about being big. So that's it. To truly understand why companies like Google, Netflix, and Tesla are winning, you have to understand the framework that defines this chaos. And we call them the four V's. Here, there's a four V's that they follow to understand and manage the data appropriately. So here, to understand that, we'll go with what? Four V's of it. So what all those four V's are? So let me just write it. So that four V's are what? That are volume, velocity, variety, and veracity. Let me write it. That four V's are what? Firstly, volume, velocity, variety, and veracity. These are the four V's that comes into this. So let's look at this one by one. So what do you mean by volume? So here, if you look carefully, that volume, as I explained already, on a daily basis, this volume is getting increased. It's not increasing linearly or something like that. It's increasing exponentially. Miss, if I have to explain, miss, what does it mean? So here, think about any big organization, Walmart, Google, LinkedIn, they are have a lot of data. Yes, they are right becoming right heavy on a daily basis. So the scale over here, the scale of everything is what the volume is. So okay, the first V over here is this volume. So this is the most obvious one. Big data means that only majorly, that is big data. Volume has been increased. So is this sheer amount of data we have moved past gigabytes and terabytes. Today we are talking about petabytes and exabytes and all the stuff. So let's say, for example, think about Walmart. They process over 1 million customer transactions every single hour. That data goes into a database that is estimated to be over 2.5, let's say, petabytes. uh, if you try to store that on standard 1 terabyte hard drives, so you would need a literal warehouse of disks. The tech behind this isn't your standard SQL database that you are gonna save all those things that, or whatever the data I am having over there. No, it's not like that. To handle this volume, we use distributed systems. So the one system is not enough. So I should go with what? I should go with the multiple sticks, multiple systems, and so on. This is not limited. We need to go with the distributed systems over here. That is, I'm gonna scale it horizontally, and also a lot of stuff are there. I will be looking. I will look into that. But firstly, let's understand this thing. Okay. So here I was talking about that in the distributed system we need to go. We used to use distributed systems. So fourth is, think of Hadoop or Spark. Okay, yeah, Hadoop is also there, Spark is also there. They both does the same thing, but the difference is that Hadoop does all things storing of it in the disk, and this Spark is much faster, 100x faster in some cases, because it does all these things in memory. Okay, we'll be looking at that. That's the different thing. But for now, let's clear the basics first. So instead of one giant computer, um, let's say this is the giant computer, instead of going like that, what I can go, what I can say, instead of this giant computer, I can say that uh, I will try to process. Uh, I, I, I won't be trying to process this into this one giant computer. I will break the data into small chunks and spread it across thousands of cheap commodity servers, just like I did over here. Some data will be here, some data over here, some data over here. So one system like this won't be heavily uh, used for reading or writing or something like that. I'll distribute based on the logic and the requirements. So this is called horizontal scaling. I'm increasing the nodes over here. I'm not dependent on one system itself, because it also helps in the fault tolerance. If let's say this system dies because of some reason, so in that case I don't need to trust this. I'll be like, yeah, I have a lot of a lot of systems over there uh, that will help me in continuing my application. That my application won't drop overnight. So here, when the volume grows, you don't buy a bigger computer. You just add more small ones to the cluster. That's what, well, volume is. That's a lot, I think so, because it's just an intro part. So that's a lot to understand. So let's jump into the velocity. That is what? That is the need for speed. So here we will be talking about the need for speed. What's that? So let's just look into this. What that means? Speed. Okay. So the second VO is velocity. That is, this is the speed at which data is generated, and more importantly, the speed at which it must be processed as well, not just the generation part. Because let's say if I am using any application, let's say Instagram or any social media application, YouTube or something. Firstly, it's the UGC, user generated content will be there, and user will be generating, and I have to process it for the utilization of it, because users are waiting as well over there. It's not just that I'm processing, generating, and that's it. No, I have to process it as well for the end user who are not generating. And there are a lot of other use cases, customers, a lot of other users who are there. For that, I need to generate and process at the same time. So in the old days, what happens that companies did batch processing. They would collect data all day and run a report at midnight. In 2025, 24, and before that, that's too slow. But now, in just 2 years, with the AI era and all those things, the data is getting increased exponentially. So let's say example, for example, let's consider, uh, let's say there's a fraud, credit card fraud. Okay, and if a thief steals your card, so it's saying that what if the thief steals your credit card, then in that case, let's say that thief buys a laptop. Okay, so the bank can't wait until midnight to flag it. Okay, this was the fraud. They need to analyze a transaction in milliseconds. This is streaming data, because if they will be doing something like that, let's say credit card is a thief using that, he bought a laptop. So but this transaction is what, this transaction is done, money has been deducted. Now in the midnight, what will happen? The money is already went out of this bank balance. So that's not the good thing. So over here, I need to stream the data in real time. I should not wait to collect it and do the batch processing. Okay. So to handle velocity, that is the speed, engineers use tools like um, Apache, Kafka, uh, Apache, Synesys, and whatnot. They use these all things for stream processing. Now, these are the message brokers that act like a massive firehouse that catching data as it happens and feeding it into real-time analytics engines. Imagine stock trading platform. Over there, what happens? That data is not like um that I am generating it and then I'll be processing it afterwards. No, it has to be real time. The speed, the velocity is it has the high priority over there. Okay, so if you're every second over here, the price changes. If a system has a 2 second lag, you lose millions. So velocity is about closing the gap between the event happening and the insight being generated. That's what velocity is and the importance of it. Okay, so now we'll be looking into the uh, variety. That is what, the chaos of formats. That means nowadays, earlier there was just textual data or some that kind of data, but now the data are not of some specific types. Now we have different types of data. So over here, the third we which we are going to discuss is the variety. Back in the day, data was neat. It fits into rows and columns in an actual sheet. But now the data is not like that. I'll be in the, it will be in the relational structure, something like that. The data has been changed. The data is not limited to that which we can fit into rows and columns and all the stuff. Earlier back like Excel sheet. That's the structured data. Today, only about 20% of data is structured and 80% of data is unstructured. So here, earlier back in the days, 100% data was structured, but slowly, and exponentially at a particular time, the data becomes that structured data ratio becomes 20, and the unstructured data ratio becomes 80. And it's not just that it will be this only, it's changing with the time, because now structured data is not just the 80% is now a different formats of data are also coming with the time, with the uh, changes, revolution in the technologies. So we need to look for the variety of data as well. So let's say think about a single YouTube video. The data includes the video file itself, okay, and in that video, let's say there's a video, okay, let's say in the video, YouTube, in this video, it's not just the video that is the before and all the stuff. It has the audio track, it has the transcript, that is the text, it has the comments, hierarchical t format, the likes, that's also hierarchical, not hierarchical, who followed in the database. I need to, that's the different thing, okay, that I won't be going that into that complexity. Likes will be under users watch history as well. So this is a mess of different formats. This is why data lakes becomes popular, unlike a data warehouse, which requires you to clean data before putting it in data lake, like data like Azure data lake, or Amazon S3, something like that. So before putting that into that data lake, um, uh, I need to make it clean. So like this, the data like this Azure data lake or AWS S3, whatever it is, it lets you throw everything in its raw format, and then cleaning has to be there or there for to do processing, and to for, let's say for the user has to what wants clear data that they want to consume. They are not gonna desegregation of all those things, okay. So we use NoSQL database here like MongoDB or Cassandra, because they don't require a fixed schema. They are flexible. If you want to add a new type of data tomorrow, you don't have to rebuild the whole system. So because of that, variety also has to be under consideration. So with this, we'll jump into the next V, that is veracity over in this case. So let's look into the veracity as well. So what does this veracity means? So now we talked about volume, we talked about velocity, now talked about variety. That's more than enough, I think so, for the data. What does this veracity comes into the picture? How does the veracity comes into the picture? What does the veracity means? So I'll explain that as well. No worries. So the veracity is the truth of the problem. The truth problem is the veracity. That is with the final V is veracity. That is the most underrated but most dangerous V. It refers to the quality and accuracy of the data. Here, okay, now the data is there, but how I can trust it? So the quality has to be there with the accurate uh, uh, accuracy on the high priority, that has to be there. So because high volume is useless if the data is dirty. Even though if I have a lot of heck of data, that doesn't matter if it's not trustworthy, if it's not accurate, if it's not a quality data. Let's say example, if I'll consider GPS, what does it do? Global positioning system. So over here, it will take what, at each time it will look for the location data and all the stuff, latitude, longitude, and all the stuff. So GPS data are coming from a smartphone. So here sometimes the uh, signal bounces off a building and says you are in the middle of the ocean for 3 seconds. So in this case, if an autonomous car, let's say, trusts that data, it crashes, because that's because of the dirty data it has, because of this signal issue or some data has captured. It was not quality data. There's not applied all the thing processing and also properly. Now it's not accurate. Car will crash over there. in mid of the ocean, at the start of the ocean itself. So that's what veracity is. Miss veracity is about filtering out the noise. Data should be noiseless. There should not be any data. This involves um, data cleaning and provenance. Engineers use ML algorithms to spot outliers and anomalies. So we have to ask where where did this data come from? Is this sensor calibrated? Is the social media bot driven? In big data, garbage in, garbage out is the golden rule. If your veracity is low, your multi-million dollar AI model will give you wrong answers. Okay, even though AI won't be able to do anything. I hope you're getting it. So with this, I wanna add one more V. That is the very important V. That's what here comes into the fifth V. Very important fifth V. That's what. That is. Let me write it. That is the very important value. Data value is the even though the other V are important, but this is the very important V which you should focus on. So what does this mean? So let's understand this as well in a beautiful way. So over here we care about the volume, velocity, variety, but value here has to also has to be under consideration, because at the end of the day, if you aren't making money or saving lives with these data, it's just digital noise. So at the end, it should save money, it should make money and save lives. Then only uh, this data has some value, or else it's the digital noise. So that we need to take under the consideration. So the architecture here is to this five is 4 is obviously is to manage these V's in his what separates the tech giants from everyone else. If you found this breakdown helpful, just build it, do it practically. Let's explore more and more. Okay, so do a deep dive onto this stack, and I will see you in the next one. Bye bye.